Looking at the fourth question for the analysis of the pendulum lab, we know that it asks, using Newton's laws, we could show that for a simple pendulum, the period t is related to the length L and the free fall acceleration g by the equation t is equal to 2 pi times the square root of L over g. The question then states, calculate the theoretical period for each trial in part 3 from your data. Let's say this is my data. It's going to be different than your data, but let's say my data is equal to, I'm going to make a little data table here in red. Here's the length that I had for part 3, and then the period t. Let's fill that data table out. I went from 70 centimeters to 75 centimeters, and then 80 centimeters, and then 85 centimeters. The period that I got for each of those was 1.6 seconds, 1.7 seconds, 1.7 seconds, and then 1.8 seconds. I could have been more precise, but I'm going to choose only to write the period in tenths of a second. So let's go ahead and do an example calculation for this first length. We want to predict using this equation right up here that t is equal to 2 pi times the square root of Lg. Predict what the period should be and then compare it to our value of 1.6. So let's say t is equal to 2 pi times the square root of 70 centimeters. I have to have the length in meters, so there are 100 centimeters in a meter. I take 70 divided by 100, that's 0.7, divided by the acceleration due to gravity, which is 9.8. Pulling out my calculator, I see that the period is 2 pi times, when I take 0.7 divided by 9.8, I get 0.07142, so forth. I'm going to take the square root of that. So the square root of that is 0.26726. Multiply that by 2 pi. Whatever answer I get is the answer that will be my period. So here we go. I'm going to make that a little bit smaller. Taking out my calculator, multiplying by 2, multiplying by 3.14. My solution is that the period we're predicting is 1.68 seconds. If we look at our predicted value, compare it to our data here, we can see that the data is pretty close to the predicted value. If we were to round this value right here, we would round it to 1.7, but you know, the data is pretty close. That's our analysis. That's the example. You're going to have to do that a total of 5 times. We just did it once. Do it 4 more times. I would do it 3 more times for my 3 more data points. You're going to do it 4 more times for all of your 5.